Okay, folks, welcome to the session. I hope everyone is enjoying the conference so far. Our topic in this session is going to be inheritance, excellent or evil. A little bit about me before we get started. I am the project manager for Parallel Fox and Fox Tabs, so check those out on VFPX if you haven't already. Besides that, I'm just like most of you. I've been doing working with Fox Pro and its predecessors for a very long time. And over more recent years, that's expanded into SQL Server, .NET, Angular, TypeScript, etc. Let's take a look at what is on the agenda. We're going to start by reviewing what inheritance is, why it is a part of object-oriented programming, and some of the benefits that it provides. Then we'll define composition and explain how it provides an alternative to inheritance. Next, we'll discuss some of the criticisms that are out there and made against inheritance and how you can avoid certain pitfalls. We'll follow that up with consequences of using composition rather than inheritance. And last but not least, we'll answer the question, is there a place for inheritance in your object-oriented designs? Now, if you have a question, please just enter it into chat whenever the question comes up, and I will stop occasionally to see if there are any questions. Before we dive in, let's find out where you stand on the matter. Now, in the chat area, you should see a poll option, and just forgot one thing. And yeah, in the chat area, you should see a poll option. And so which one of these would you choose? Do you think, 1, inheritance is excellent. I love it and use it often. 2, inheritance is okay. I use it when it makes sense. 3, inheritance is evil. I avoid it when possible. Or 4, what is inheritance? Now, there is no right or wrong answer, so just please choose based on your personal opinion. And just watching the results come in. And it looks like I agree with about 57% of you. I think inheritance is excellent. I just think it's a beautiful thing, and I enjoy the power and elegance that it can bring to designs. But that's just my personal opinion. As I said, none of the answers above are incorrect. In fact, whatever option you chose, this session aims to give you food for thought. But what are other people saying about inheritance? Well, let's ask the all-seeing master of all knowledge in the universe, Google. So I'm going to search for inheritance is evil. And there are no shortage of results here. Inheritance is evil. Stop using it. Inheritance is evil and must be destroyed. Is inheritance a bad practice? Good question. Yes, inheritance is usually a bad practice. Why inheritance is viewed as a bad thing? Inheritance is indeed evil. Why inheritance is bad? Implementation inheritance is evil. Starting to lose my breath here. Only when we get to the final result on the last page do we get a more balanced view of this subject. But you know what? I got what I asked for, right? So let's go with inheritance is excellent. So I get some general information about inheritance and maybe some beginner topics, but I don't see anyone proudly proclaiming that inheritance is excellent. And wait, what's this? Inheritance is evil? Really? In the excellent results? Well, there you have it. Google has spoken. Inheritance is evil. I feel judged, Google. Do 46% of you now feel judged? Or some of you thinking, I should have gone with option 2? Or does this idea that inheritance is somehow a bad practice, does that surprise some of you? Well, for me, I got to say that's a little hard to swallow. Something is wrong here. It just doesn't feel right that one of the pillars of OOP should just be thrown out. Sorry, Steve, but your services are no longer required. Yeah, I decided I'd better dig a little deeper into this topic, see what these folks are talking about, and I did find some alternate points of view. Here's that article we found at the bottom of the Google page, Composition versus Inheritance, How to Choose. In that article, Stephen Lowe wrote, I am not a fan of mantras. I am also not a fan of ridiculous clickbait headlines like inheritance is evil, especially when the author attempts to back up such an outrageous claim by using inheritance inappropriately and then blaming inheritance. I have a few other quotes from some people you may have heard of. Inheritance is an essential element of object-oriented systems. Grady Booch said that in his book. Anyone heard of Grady Booch? Or how about Martin Fowler? Lots of pundits like to disinheritance. Sure, it can be misused, but it pays to learn to use it well. Or maybe Steve McConnell. Inheritance is one of object-oriented programming's most powerful tools. It can provide great benefits when used well, and it can do great damage when used naively. So these are the folks I tend to listen to when it comes to object-oriented design. And these quotes ought to instill the idea that object-oriented architecture is a thinking activity. It's not something you can do by following a set of pre-canned rules. And that inevitably means that the decisions you make are going to be subjective, and they should be, right? Many of the factors beyond just best practices come into play to define your situation. Things like the existing code, the development tools you use and their capabilities, the size and the makeup of your team, and yes, even your personal preferences. Thinking for yourself. Now, I don't think that's a problem with this audience, right? How long have they been telling us to stop using Fox Pro? But as you're expanding your knowledge into new areas and you're trying to learn the quote unquote right way to do things, it can be difficult to separate best practices from dogmatism. And this idea that inheritance is a bad design choice, it has permeated the industry to some extent. Now, this session, it doesn't aim to create or regurgitate any rules for you to follow. Rather, I just want to explain what some of these notions are, why they're out there, and just give you some things to consider. And then when you have that knowledge, you and your team decide if, when, and how to use inheritance in your applications. So let's get into it. First of all, what is inheritance? Now, I'm sure most of you know and understand what inheritance is, but let's review. Inheritance defines and is a relationship between classes. For example, a customer is a person. An employee is a person. And as people, customers and employees, they have certain things in common. And the things that they do have in common can be placed in this person class. Things like the ID, the first, middle, and last name. Then the customer class can be created as a subclass of the person class. And by doing so, it automatically inherits all of the common things from the person class, these properties. So that whenever you use the customer class, you automatically see the ID, first, middle, and last name on that class. And the same thing for the employee class. It inherits from person as well. And as we'll discuss, this is a very powerful mechanism, but it can lead to problems if used unwisely. So how did this idea of using inheritance in programming emerge? And to answer that, I think we first have to answer, why do we use object-oriented programming? By that, I mean, why do we collectively use OOP? Well, if you Google this question, you might be surprised as I was that there's really no clear answer to this question. Sure, there's tons of information out there about OOP and how to use it, but I could not find this grand unifying statement that everyone points to as the reason we use it in the first place, the original motivation behind it all. But after researching the topic, I have gathered the following. And that is that the goal of object-oriented programming is to classify and organize code to align with the way the human mind thinks. So Grady Booch in his book talked about that it's all about managing this ever-growing complexity in software. It's about acknowledging the limitations of the human mind and just reducing the cognitive load on developers. And by aligning with this way of human thinking, it's really just about making these systems easier to understand. Well, let's bring this back to inheritance. As humans, we tend to think about real-world objects in relation to other objects and in hierarchical fashions. Well, what do I mean by that? Well, there are two key hierarchies that we use in the way that we think. The first is that is a hierarchy or a relationship that I talked about previously. So take atoms, for example. There are different types of atoms: hydrogen, carbon, oxygen. Thinking about each type of atom helps us to understand it better, but it's also useful to think about atoms in a generic or abstract fashion because all atoms share certain traits. Now, can you imagine removing the term atom from our vocabulary? Or how about hydrogen, carbon, oxygen? No, you wouldn't do that because both levels of detail are useful. And this is the mental hierarchy that inheritance provides. When folks talk about not using inheritance, it's almost like saying, stop thinking like this. And that's difficult to do. But we also tend to think about things in a different way and in a containership hierarchy. And this is often referred to as a has-a relationship between objects. Atoms are composed of protons, neutrons, and electrons. Oxygen specifically has 8 protons, it has 8 neutrons, and it has 8 electrons. Molecules are composed of multiple atoms. A water molecule has 2 hydrogen atoms and 1 oxygen atom, H2O, right? And an ocean has a vast number of water molecules. So this mental hierarchy, it's also key to describing and understanding the world around us. And in object-oriented programming, this is referred to as composition. Now, you might have noticed that these hierarchies can intersect, right? Hydrogen is a type of atom, but it's also a specific composition of protons, neutrons, and electrons. So this gives us a clue that both inheritance and composition come into play with the way the human mind thinks. And we need both ways of thinking to make sense of the world around us. And that's ultimately why both inheritance and composition are part of object-oriented programming. Now, as we just mentioned, inheritance establishes that important is a relationship between objects, but there are several other benefits as well. And you can't talk about inheritance without first and foremost talking about reusability. It allows you to specify common things in one class and then reuse that class throughout your application. And the classic example is the text box. So here I have created my text box class that is a subclass of the built-in text box class provided in Visual Fox Pro. And I've specified a few properties: font name, font size, select on entry. And then there's that piece of code we all add that makes select on entry work right when you click in the text box. And this my text box class is going to be used throughout my application rather than the base text box class. And if I ever need to change the font or some other property or tweak the behavior or fix a bug, I can do it in one place. and it's reflected everywhere the class is used. I can also use my text box as the basis for another subclass. For example, I could create a my date text box that inherits from my text box. That allows me to reuse the code I've added to my text box, but also specialize that class for dealing with dates. Another benefit of inheritance is programming by exception. Inheritance allows you to create classes that specify only the differences from the parent class. So my text box is exactly like the built-in text box, except for the properties and methods that I have specified. My date text box is exactly like my text box, except for the changes I have made to support dates. And this just results in less code to create and therefore maintain. Can you imagine having to recreate the base text box class just to make changes to it? Inheriting from an existing class provides a starting place for the subclass. And this isn't just in terms of code, it's also in terms of the design. When you're subclass, you don't have to think about the entire design of that subclass because most of that work has already been done in the parent class. You can create a fill-in-the-blank structure by creating parent classes that are abstract classes. And these are just classes. They're never intended to be instantiated directly. They're just intended to be subclassed, and then those subclasses may be instantiated and used directly. And this is usually because the abstract class is incomplete. It has some blanks, right? So it needs subclasses to fill in those blanks and do whatever needs to be done. So the abstract parent class, it contains the common behaviors that all of those subclasses are going to need, but then each subclass provides additional details required to complete a specific implementation. Let's talk a little bit about polymorphism, and that is basically the idea of providing a common interface that's used across multiple classes. And by that, we mean multiple classes have one or more methods or properties with the same name, and those methods accept the same parameters. This supports the principle of coding to interface and not implementation. In other words, the calling code, the code that calls this objects, only requires that a method or property has a specific name and parameters. It doesn't require a specific implementation, or it doesn't really care what goes on within the class as long as the interface is what is expected. And a good example of this is the refresh method that exists on most UI classes in VFP. First of all, aren't you glad they called it refresh everywhere, right? It's not refresh here, reload there, update somewhere else. Using this one term provides consistent expectations. It helps us understand it better. But beyond that, VFP provides functionality, built-in functionality that I'm sure you're all aware of, and that is that whenever you call the refresh method on a form, it also calls the refresh method on any objects that are contained within that form. And the reason that works is because those objects have a method named refresh on them. That's polymorphism in action. Now, when designing your own classes, some languages such as C# and Java, they provide a specific mechanism for defining these interfaces. And you can just think of an interface as a class with no code in it. It only just defines the methods and the properties that a class must implement. So it exists solely for ensuring this polymorphism across these multiple classes. Well, what does this all have to do with inheritance? Well, if your language supports that interface syntax like C#, then yes, you should use that syntax. But other languages like VFP don't have that. And in that case, inheritance is a good way to provide polymorphism. Right? If you define some methods on a parent class, those methods, the interface carries down automatically to the subclasses, and you get polymorphism as a benefit of that. Check the white paper for an example comparing Java C# interface to an approximation using VFP. A couple more benefits. Extensibility, the open-closed principle. That's the O in solid, a set of object-oriented design principles. And it states that software entities should be open for extension, but closed for modification. So when you're adding new functionality to a system, this states that it's preferable to create a new class that extends the existing class rather than modifying the existing code of the existing class. So, for example, we previously talked about that my date text box. Now, of course, I could have modified my text box to add functionality for dealing with dates, but that might have caused problems to any existing instances I had out there of the class, and especially those that weren't dealing with dates. So this principle just recommends creating a new class and rather than modifying the existing class and potentially breaking it. And inheritance is just a natural way to provide this type of extensibility. Last but not least, inheritance provides convenience. Now, some might say, actually, convenience should be least, right? It should be at the bottom of the list of concerns. And it may seem like a little thing, but convenience is really one of the key things that makes inheritance so attractive. When I create a subclass, it automatically inherits all of the properties and methods of the parent class. That's convenient. That means less typing, which is convenient. And that translates into fewer bugs due to typos, even more convenient. Since I'm also inheriting the design of the parent class, I don't have to think through the entire design of my subclass. If I change the font in that my text box class, that change is applied everywhere that class is used. That's super convenient. So conveniences like this save time. They make me feel more productive. They reduce the drudgery that can come with writing code. So maybe convenience isn't really such a small thing after all. It can be a powerful motivator. Think about the convenience afforded by your smartphone or your TV remote control. Would you give up those conveniences now? Or think about how much effort developers put into being lazy to provide conveniences. It's not really about laziness, though, is it? It's just about avoiding these repetitive actions that feel like a waste of time so that you can focus on the more meaningful stuff. Now, of course, convenience should not drive all of your decision making, but it shouldn't just be thrown out either. Don't discount it as an invalid concern when it comes to your designs. So after all that, inheritance sounds pretty good, right? So if it is so great, why is there all this negativity surrounding it? Well, before we get into that, are there any questions?
The only question we've had so far is, where did you get your video clips from?
That's, I think it's jiffy.com, which everybody uses, Twitter, whatnot.
That's it. That's the only question.
Okay. Okay, so composition versus inheritance. Where did this idea that inheritance is somehow bad come from? Well, in their arguments, many will point to this statement from the Gang of Four, the writers of the Design Patterns book. And that book states a principle which says favor object composition over class inheritance. And there's a section in this book dedicated to this topic, and it definitely is worth a read if you get a chance. In fact, if you haven't read it in a couple of decades like I hadn't, you might be surprised how much better you understand it now. But what did the Gang of Four actually mean by this? Well, here are a couple other quotes from that section. Inheritance and composition each have their advantages and disadvantages. Inheritance and object composition thus work together. It doesn't sound much like an indictment against inheritance, and it certainly isn't declared evil, is it? But let's continue with the final paragraph in that section where it says, nevertheless, our experience is that designers overuse inheritance as a reuse technique, and designs are often made more reusable and simpler by depending more on object composition. So I don't read this as saying necessarily that inheritance is bad, rather that inheritance was often relied on too much as a mechanism for reuse, and that there are benefits to using composition. Well, context is everything, right? Design Patterns was released in 1994. And while object-oriented programming had been available for a long time, it was really around this time that it emerged as the dominant programming paradigm. Windows' popularity was on the rise, and OOP, it just proved to be a good fit for this graphical user interface development. And of course, for many of us, were introduced to object-oriented programming at this time, around this time with the release of Visual Fox Pro 3.0. In other words, there were a whole bunch of developers that were new to OOP at the time. And to developers entering this new land, inheritance was just really easy to latch onto for all those reasons I stated before. The reusability, programming by exception, the extensibility. Let us not forget the convenience. So it was just this exciting new approach, and the practicality of it all just made a whole lot of sense. And thus, the love affair with inheritance began. It just felt so right. To newcomers, inheritance was often touted as the reason to use OOP. And so for many, it just became that go-to method anytime you needed to reuse code. And they also set about developing these creative and clever ways of using inheritance in their designs. So it was in the midst of all of this that the Gang of Four is saying, hey, inheritance has its place, but maybe it's not the answer to everything. There's this other thing called composition that opens up a lot of possibilities. So that was good advice. It was good advice then, and it's still good advice today. New developers can fall into that same pattern of thought, or even experienced developers might need to break free from old habits. So let's learn more about composition. And to start, what exactly is it? Well, it's that has a relationship between objects we talked about, as opposed to the is a relationship that inheritance provides. So it's a containership relationship. And you have probably used composition hundreds, if not thousands of times when composing forms in your applications, right? A form has multiple controls, and one of those controls might be a page frame. A page frame has multiple pages, and each of those pages has multiple other controls. Let's go back to that principle stated in the Design Patterns book. Notice that it says favor object composition over class inheritance. Inheritance is a relationship between classes. What exactly does that mean? Well, when you instantiate a subclass, you don't have to worry about also instantiating the parent class, right? That's because the relationship has already been set up at the class level. And when you define an interface an inheritance relationship between classes, you do gain certain conveniences and productivity benefits, but you could say that relationship is hard-coded, so to speak. It's locked in, right? Composition, on the other hand, is a relationship among objects, and the relationships among those objects, they're established after the objects are instantiated. And by doing that, you gain more flexibility when setting up those relationships. So to understand composition even better, let's take a look at some business classes that use an inheritance structure and see how we might transform those to use composition. So in this diagram, our three classes are back, but we filled them out in more detail. So our person class still has our ID and name fields, but I've added some address properties. And then we also have a couple of methods, get full name and validate address. And our customer subclass has a couple of properties that only apply to customers, discount and credit limit. And in the same manner, employee has a couple of properties that just apply to employees, hire date and salary. So let's take a look at the code for this. And it looks exactly how you would expect, right? You've got your properties defined here for the name and address. You've got the get full name method, validate address. And here we've got customer as a subclass of person and those two properties that are just for customers. And then we've also got the employee, which is also a subclass of person, and the two properties that are defined for it. So how do we transform this is a relationship to a composition has a relationship? Well, if we simply copied all of this code and pasted it into the customer class, and then also copied and pasted it into the employee class, well, that would be duplication, not composition. Composition is still about reusability. So one thing we could do is make the person object a member of both classes. And that means adding a person property to both the customer and employee classes that would be a reference to the person object. And in this diagram, we see that for the customer. So this symbol here, the diamond with a line, that means that this customer object has a property on it named person, and then that person property is a reference to this separate person object. And technically, this is composition. And in some cases, the transformation would be complete. But let's say this out loud, okay? We previously said customer is a person. Now we're saying customer has a person. Doesn't sound right, does it? So how do we rectify that? Well, we can say a customer has a name and a customer has an address. That makes sense. So what if we split those into separate classes and then compose them into the customer class? And that would look like this. So I now have my name class. It has the three name properties as well as the get full name method. And I now have a separate address class as well with the address properties and the validate address method. And so now those are both members of the customer class. This means the customer has a name property that points to that separate name object. And it also has an address property that points to that separate address object. And we can do the same thing with employee, right? These are the same two classes, the same code as before, but we're using them with the employee class as well. So by doing this, we have successfully reused the name and address functionality via composition rather than inheritance. So let's see how the code looks for that now. So here at the top, I'm first defining this name class, and it has the name properties as well as that get full name method. Same thing for address. It has the address properties and that validate address method. Now notice here that the customer class, it's no longer a subclass of person, right? It's just based on the built-in custom class. But we have added a couple of new properties for the name and address, and then those two objects are instantiated in the init of the customer class. And the same thing happens for the employee class. It's also not a subclass of person. It is defined as custom, and those are instantiated in the init. So now that you've seen both approaches, which is better? Well, especially in this case, there's no clear winner, right? It's entirely up to you. But I do hope that by going through this, you have a better understanding of what composition is. And in fact, let's keep going. So our manager has arrived with a new requirement for us. So currently, names are displayed in the system as first, middle, last. And that's great, but we found that there are certain parts of the system where we need to display in a different format, last, first, middle. So the application needs to support both methods of formatting the name. And that is handled in this get full name method of the name class. And sure enough, that is defined as first, middle, last. Now, of course, we could add a parameter here to select which format to use, then have some kind of conditional statement in here, doing an if or a case statement. But our Jedi censuses are telling us that additional formats might be required in the future. So we decided to take a more object-oriented approach to the issue. And we come up with a design that looks like this. So in this diagram, the iname formatter provides an interface for these first, middle, last, and last, first, middle formatter classes. And this I is just a naming convention that is usual in C#. And it just means that this is an interface and it has no code. It only defines the name and the parameters of this format name method. Sorry, I'm losing my mouse. So notice that this line and symbol between the name and the format, iname formatter, it's a little different than we saw before, right? Previously, we saw the diamond with the solid line. Well, while you could say that the name has a formatter, it would really be more accurate to say that the name uses a formatter, or we could say that the name depends upon a formatter. And so this formatter is called a dependency of name. And you'll hear that term dependency terminology whenever you're working with composition. The relationship is just a little bit different. And the difference between a component, which is that has a relationship, and a dependency, which is that uses a relationship, it's subtle. So don't get hung up on it. But ultimately, it all falls under composition. Also notice that the dependency that uses a relationship, it's drawn from name to the iname formatter. It's not drawn to these classes that implement the interface. In other words, we're coding to interface, not implementation. And we could add any number of classes down here. And as long as they implement that iname formatter interface, in other words, as long as they have this format name method on them, then they can be used by the name class. And the name class doesn't really care what goes on inside of the code. So let's take a look at how that comes across in the code. So here I am defining first that iname formatter interface. And as I said, it's just an interface only, so we don't have any code in this class. And it just defines the name and parameters of that format name method. Now we've got this first, middle, last formatter that implements this iname formatter interface. So here we see the format name method here, and here's that first, middle, last code. Now we have another formatter here, last, first, middle, implements the same interface, format name, except now the name is formatted in a different order. So going down to our name class, it looks the same as before, except we now have this name formatter property, and that is instantiated in the init, right? Where as a default, we're instantiating this first, middle, last formatter, but the outside calling code could change that after the fact. And now our get full name, it delegates the responsibility of formatting that name to the name formatter. Now, you might not like the fact that we are instantiating a default here, right? If you don't need first, middle, last format, then it's just wasted clock cycles by instantiating a default in the first place, right? Or go back to our person composition code. Especially if you're coming from inheritance, does this duplication of code here I've got in the customer class, I've got the same code here in the employee class. Does that make you a little bit uncomfortable? Well, modern development techniques actually emphasize a different approach, although you might find it makes you even more uncomfortable. And that is that these days composition is usually performed externally to the classes rather than internally like you see here. So that is to say that it's not the responsibility of a class to create or instantiate its own components and dependencies. That responsibility is shifted to the calling code, and there might be some framework that comes into play as well. But with this approach, the customer and employee classes would not instantiate their own, the name and address objects. Or going back to the name formatter, it would not instantiate the name formatter dependency. Rather, both would be instantiated by the calling code. So let's see how that would look for the customer class. So I have a section of code here that is performing all of the composition necessary to use the customer class. So here we're first instantiating the name formatter, and in this case we chose first, middle, last. And then I'm instantiating the name object next, but notice I'm passing the name formatter as a dependency to the name class. So if I scroll down here, you can see in the init, I'm accepting the name formatter as a parameter. In fact, I have an assert here because it's a required dependency. So if you forget to pass it, then it's going to pop up a message saying, hey, you forgot something. And then the name formatter property is then set to the name formatter that's passed in. Scrolling back up, I'm also next creating the address object. And then I create the customer object and set the name and address to the two objects I just created above. Lastly, I'm just setting the name and printing it out. So let's run that code. And you get it in first, middle, last format as you would expect. Now, since I am doing this externally, I now have the flexibility from the calling code to determine which formatter is used. So now I've just changed that to last, first, middle, and I run the code, and now I get it in the expected format. As you're looking at this, can you feel the tension between flexibility and convenience? In order to use the customer class with a composition structure, I now have to instantiate 3 other classes. In our previous inheritance structure, I could simply instantiate customer and start working with it. So in some ways, favor composition over inheritance could be restated as favor flexibility over convenience. And that is composition in a nutshell. Do we have any questions?
The only question we have is from Phil. He says, any discussion of garbage collection when using composition?
We are going to mention that later, but not in a lot of detail.
Okay, that's it then.
Okay. So I hope we have established that on its own, inheritance is not evil, but there are some issues and some warnings we saw out there, right? If used unwisely, you can paint yourself into a corner, and there are some legitimate concerns. So let's consider some pitfalls often associated with inheritance and how they can be avoided. And rather than trying to speed through all of the potential issues, I picked just a couple for us to focus on. And the first is God classes. Now, a God class is just a class that provides too much functionality. And a typical example you might have run across before is a single global application object that just provides all sorts of functionality to the rest of the system, like a Swiss Army knife of code, so to speak. But this situation can also occur when using inheritance. As we're working through our application and we discover classes have common needs, it's easy to just push up that functionality into a parent class. Now, while designing these classes, it's good to consider the single responsibility principle. That's the S in solid. And that basically says that a class should have a single responsibility. Okay, what exactly is a single responsibility? Well, the official description of this principle is that a class should have only one reason to change. Well, that explains everything, doesn't it? No, not to me. It really doesn't help much. So it may be easier to provide an example of what is not a single responsibility. And so let's consider these Visual Fox Pro base classes that you all have worked with. All of these controls are used to set a single value. Now, what if instead of providing these classes, Microsoft have given us one class that was called single value control? And then if you wanted it to behave like a text box, you set a property on that single value control that set it to text box. Or maybe you wanted to use a combo box and you set a property to combo box instead. Yeah, that would seem like too much in one class, wouldn't it? It would be harder to use and harder to understand. Not only that, there would be some members that didn't apply, that only applied some of the time, right? Combo box and list box, they both have row sources, but a text box doesn't. So if you put all of this in one class, you find that you have some properties that are only used in certain cases. And that's a clue that you've got too much going on in one class. And in this case, it would just feel all wrong. So single responsibility principle, it's really about just finding that right level of responsibility for a class. And beyond that, it's just a question of granularity. How large or how small do you want a class to be? And that's totally subjective. So as you're working with your classes and these commonalities emerge, contemplate the taxonomy of your class structure, right? If you've got something that's common and you push it up into the parent class, are you going to expand or swell the responsibility of that parent class and just stray too far from its original role? If so, it might make more sense to push that common functionality out into a separate class and then reuse that functionality via composition rather than inheritance. Another issue, what I call services for subclasses, and you might have heard it called by different names like convenience methods, helper methods, utility methods. These are what we sometimes call features that are added to parent classes with the express goal of providing subclasses with quick and easy access to that functionality. So these are methods. They're not intended to be used by the parent class. They're not intended to be used by the external calling code. They're really put on the parent class just to make them easy to call from subclasses. And while this is very convenient, it is not a parent class's responsibility to serve up functionality to its subclasses on a silver platter. And that's not a goal of inheritance either. So as I would tell Will Ferrell and my 3 adult children still living at home, the meatloaf is in the fridge. You are welcome to get it yourself. And I think avoiding this practice goes a long way towards diffusing some of these criticisms of inheritance, because I think this is what a lot of critics are seeing out in real code. And in fact, I have been guilty of doing this myself. So we use a commercial framework, application framework with our flagship application, and it's good. It provides a lot of features for desktop and client server applications, but really doesn't provide much in the way of in-tier development, and particularly the middle tier. So it's been nearly 20 years now, but I developed a base class for that purpose. And that is just a place to put our business logic of our application. And it looks something like this, this diagram. So this data handler class, that's provided by the framework. But I found its interface rather complex and bulky. So I developed this ABiz, an abstract business class, just to provide a simplified wrapper to the data handler. So I wrap the most commonly used methods with simplified versions. So that's what these are. They call a method in the data handler, but they accept fewer parameters and they're just easier to work with overall. But this ABiz class also serves as a base class for our business logic. So we create a customer biz object. It's a subclass of ABiz, and then we add some business logic to that class. So while I am working with that, I need to add a record. I can simply call this.addRecord, and the functionality is just very conveniently there. Or the same thing, if I need to commit the data, I just call this.save. Now, most of these members are marked as protected, and that's indicated by this pound sign here in the diagram. And this was done to respect encapsulation. So if a developer was working with this customer biz class, they would only be able to work with this, to call this do customer stuff method, right? We didn't want them to have to worry about calling all of these other methods that are really just implementation details, so to speak. And so by designing it this way, these methods really are there just for the convenience of the subclasses. And this provided a high level of convenience and consistency, and it worked great for years until I needed to access some functionality in a true interior fashion from .NET. So from .NET, I could call, do customer stuff, and that worked well. But then I ran into some scenarios where I was like, you know what? I really do need to call some of these methods that are in this ABiz class. But I had marked these as protected, so they were not available to .NET. .NET could not see them or call them. And by making them protected, I had locked up the functionality that was in this class so that it could not be accessed externally. I had actually, in the process, made the code less reusable. Now, in hindsight, the problem isn't just about the visibility of these members. The parent class really should not have been providing these services to the subclasses in the first place. The wrapper around the data handler should have been just that, a separate wrapper class that provided all that simplified functionality, but could be used by the business class via composition. So the customer biz would, via composition, use the data adapter, which would then use the data handler. And this would have made the functionality reusable, not only from my business classes internally, but also from .NET. Now, while I am criticizing design choice I made all those years ago, take a look at this typical controller code from ASP.NET MVC. Now, you might not be familiar with MVC, and that's okay. Just very quickly, this product controller class is a subclass of the built-in controller class that comes with MVC, provided by Microsoft. And when you enter a certain URL, that gets routed to this index method, which then returns a view. And that's just some HTML rendered by the server and eventually returned back to the browser. Now, what may not be obvious here is that this view method is actually defined on the controller. And the reason it is there is just to provide a convenient way to call it from the controller subclass. Wait, didn't I just say that was a bad thing? And here Microsoft is doing it in a major popular framework. Well, it just goes to show there are no hard and fast rules when it comes to design. And I can only assume that Microsoft's desire to support this program model, something that looks like this and is very easy to use and understand, outweighed any objections they had to using inheritance in this manner. In other words, convenience matters, right? That said, behind the scenes, the view method, it simply forwards the request to another class to handle the rendering. There's not much going on in this view method, right? So you can see here, whenever it's called, it just creates a view result class object, and then the view result object is responsible for actually rendering that HTML. So if you choose to have these convenience methods in your designs and making them available to subclasses via inheritance, then it does make sense for them to be very thin wrappers to other classes where the real functionality resides. So the moral of this long story is don't lock up functionality in a parent class that can only be accessed via inheritance. Okay, well, that, as I said, we just had time to go over a couple of the concerns, but there are more concerns in the white paper, and I encourage you to take a look at them. Do we have any questions?
No questions at this time.
Okay. So while composition has definite benefits, offers more flexibility, it's not all roses on that side either. So as with most decisions, there are trade-offs to be made. And as we've discussed, composition often trades convenience for increased flexibility. So what are some of these consequences? Well, composition requires composition, right? The components and the dependencies of an object must be created and assembled just for you to be able to use that object. And especially when you're dealing with high-level code that pulls a lot of things together, a large number of components and dependencies might be required to accomplish a task. And it can be a chore to assemble everything that's needed. Now, on some platforms, utility frameworks have been created, things like inversion of control containers, dependency injection frameworks. We're not going to go over these things, but they do some of the composition automatically and reduce that level of inconvenience. Composition typically requires more code than inheritance in order to assemble all those objects, right? More code means more typing, which means more typos, and it's likely that your copy and paste is going to increase as well. So when you're performing repetitive tasks, doing a lot of things that are similar, when you use inheritance, right, you're inheriting from an existing class, and that gives you a starting place for when you're creating each new class. Well, with a composition, you might find yourself copying and pasting an existing class or a piece of code to provide that starting place. And of course, that leaves more room for error. So let's take a look at that. See if I can find my mouse. So here is that block of code that we use to compose the customer object. And composing an employee object would be very similar to this. So what are the chances I will copy and paste this code as a starting place for my employee object? 100%, right? I'm not going to retype all of this information. In fact, let's do that. I'm going to get some new program here. Control C, Control V. And now I just need to change this to employee, and I'm done. What did I forget to do? Well, this code is functional, but I forgot to change the name of the variables from customer to employee. So whenever I come back to this, or where someone else does, months or years later, we're going to be scratching our head, right? Is this code about employees or is it about customers? Now, this is a copy and paste problem. It's not a composition problem, but it is more likely to happen when you're performing these repetitive actions that come along with composition. So another consequence is using composition can add a layer of containership. So what does that mean? Well, when we use the inheritance structure, right, we could just access customer.lastName was directly on that customer object. When we transformed and refactored into composition, we added an object in between here, right? Customer.name.lastName. Not a big deal, just a few more characters to type, except that this is exacerbated on FoxPro because it does not provide IntelliSense for properties on classes. So let's see what I mean by that. So here is our previous customer object that I've defined using inheritance. So if I just press a dot, of course, I get IntelliSense, and there's the last name field. After refactoring that into composition, I now have customer.name dot, oops, dot, and I get nothing, right? And that's just a limitation of the Visual FoxPro IntelliSense system. Now, there are a couple workarounds to this. IntelliSense X has a way to get around this. If you have Thor, I think you probably already have IntelliSense X. And also check out Doug Hennig's favorites for IntelliSense. Both of those provide workarounds to this problem. They both require some additional setup to get it working, but you can get your IntelliSense here. Out of the box, what you can do is just define a separate variable for the name, and that allows you to provide the type information of FoxPro, and then you set that variable to the customer.name, and now when you access that variable, LOName dot, now you get the IntelliSense for the name. Okay, a couple other FoxPro specific issues, data sessions. So if you want to share data, and by data, I mean cursors, tables, views. If you want to share that across multiple objects, you have to make sure that they all use the same data session. Now, this is usually not going to be a problem when you're creating all those objects around the same time, but there might be scenarios where you create them at different times. For example, maybe you have an object that you create at startup and you want to keep it in memory. And then later on, you create another object in a private data session, and then you want to share cursors or tables with those two objects. It's not going to work because they're in different data sessions. So if you run across that scenario, you need to provide some kind of mechanism where you can switch the data session of an object and then get them both objects on the same page in the same data session, and then they can work together. We had the question about garbage collection. Yeah, whenever you are using composition, you've got more objects that are working together. So as a result, you need to be on guard against dangling object references. And in some cases, you might have to write code to manually do the garbage collection. And yeah, I don't have any examples for that, but there is an article, good article on the Fox Wiki. Just search for garbage collection, and you'll see some examples of how to do this. So how are we doing on time? Yeah. Do we have any questions?
No questions.
Okay. So based on what we have learned, are there good uses of inheritance? Maybe even cases where you should use inheritance. And I believe the answer is yes. And this is basically a review of some things we've already talked about. So inheritance is appropriate when there truly is. This is a relationship between a parent class and a subclass. In other words, that subclass is a specialized version of the parent class. And we previously talked about my text box. It is truly is a text box. And that means that it functions and maintains everything you expect from a text box, but it just specializes it further. We talked about polymorphism, right? And if you're using a language like C# or Java that provides that interface syntax, then yes, that syntax is preferred for those environments. But in languages like VFP, it is appropriate to use inheritance to provide polymorphism. As we discussed in the open-close principle, when extending existing behavior, and especially with old code, it's preferable to create a new class that extends the existing class rather than modifying the existing class, and inheritance is a good way to do that. Abstract parent classes, they're by definition, they're incomplete, right? And they're intended to be completed by subclasses. This provides that fill in the blank structure we talked about. Inheritance is built into this design. In the template method design pattern, it's a good example of that, and that's described in more detail with an example in the white paper. And frameworks tend to make use of this fill in the blank structure, right? So framework provides a place for you to plug in code, and then the framework calls your code, unlike a library where you usually instantiate and call code on the library. It's sort of a reversal of that. So, and frameworks often provide classes to give you a starting place for your own code. And if that was designed with inheritance in mind, then it's suitable and might even be required by the framework to use inheritance when adding your own code. And beyond that, when inheritance is already in play with these frameworks, it is appropriate to subclass and specialize those framework classes and then use your subclass throughout an application in place of the framework-based class. So just be careful not to expand the responsibility and add on too much stuff to the subclass. The decorator design pattern, that comes up a lot when you're talking about inheritance. It offers a flexible alternative to inheritance when you're extending the functionality of an existing class. It's composition, but it does look a lot like inheritance, except that you manually wire up some calls between the classes. And let's see, how am I doing? Yeah, I think we have time to take a look at an example of that. So here I have what I've called a base class, and it has two methods, method 1 and method 2, and it just prints out the name of the method. And then I have what I'm calling a decorator. And notice that this decorator has the same interface, right? It has method 1 and method 2 as well, but it accepts the base class as a dependency, as a parameter. And in method 1 here, I've chosen to just forward the call from the decorator to the base class. This looks a lot like do default, doesn't it? Or in method 2, I've chosen to override and not send the call to the base class. So then if we look at how this is used, I first instantiate the base object. Then I instantiate the decorator and pass in the base as a parameter. And now I'm calling these two methods on the decorator, not the base. So if I run that, it looks how you would expect, right? I passed through the method 1, and then I overrode method 2. So using this type of structure, the decorator design pattern, it does provide more flexibility. And if you need that flexibility, then by all means use this pattern. However, if your needs don't extend beyond what inheritance provides, and my example here does not, you are basically reinventing inheritance to avoid using inheritance, except you don't have all the conveniences that come with inheritance built in. You don't have to do this. Inheritance doesn't have to be avoided on principle. Okay, do we have any final questions?
Nope, no questions.
Okay. So let's wrap it up. In conclusion, inheritance is a valuable concept that deserves its place as one of the pillars of object-oriented programming, and it should not be dismissed out of hand. That said, it is a powerful mechanism, and it can lead to problems when not handled with care. At the end of the day, inheritance is just one facet of object-oriented programming, right? One of these many patterns and practices that we use to solve problems and to just enrich the overall development experience. Each has its place, and it's part of what makes object-oriented programming as a whole an excellent approach to software development. So of these facets, encapsulation is excellent. Polymorphism is excellent. Composition is excellent. And yes, when used wisely, inheritance is excellent. That's all, folks. Thank you, everyone. Please fill out your evaluations. We will be having a breakout Q&A session right after this. So join that session if you have any questions or if you just want to discuss, and enjoy the rest of the conference.